security and NAT policies. Now we'll learn about security policy fundamental concepts, security policy administration, network address translation, source NAT configuration, and destination NAT configuration. This diagram is a simplified version of the flow logic of a packet traveling through a Palo Alto Networks firewall. The course will reference this diagram to address where specific concepts fit into the packet processing sequence. For more information about the packet handling sequence inside of a PAN-OS device, see the Packet Flow Sequence in PAN-OS document available on the Palo Alto Networks support site at live.paloaltonetworks.com/docs/doc1628. Security Policy Fundamental Concepts. All traffic traversing the data plane of the Palo Alto Networks firewall is matched against a security policy. This traffic matching does not include traffic originating from the management interface of the firewall because, by default, this traffic does not pass through the data plane of the firewall. You define security policy rules on the firewall using various criteria such as zones, applications, IP addresses, ports, users, and host information profile or HIP profiles. You can define security policy rules to allow or deny traffic, starting with the source and destination zones as the broad criteria. Then fine-tune the rules with more granular options such as source and destination IP addresses, ports, applications, URL categories, source user, and HIP profiles. The Palo Alto Networks firewall is a stateful firewall, which means that all traffic passing through the firewall is matched against a session, and each session is then matched against a security policy rule. Each session is identified by a six-tuple consisting of source and destination IP address, source and destination port number. For non-UDP TCP traffic, different protocol fields are used. Protocol and source security zone. Each session is assigned a unique session ID number. A session can consist of one or two flows, the client-to-server flow, or C2S flow, and the server-to-client flow, or S2C flow. The endpoint where the traffic initiates is always the client, and the endpoint where traffic is destined is the server. When you define security policy rules, consider only the C2S flow direction. Define policy rules that allow or deny traffic from the source zone to the destination zone, that is, in the C2S direction. The return S to C flow does not require a separate rule because the return traffic is automatically allowed. To display your security policy rules in the web UI, browse to Policies, Security. Each logged-in user can customize their web UI display. Modify the number of columns displayed by clicking any column header and selecting from the list the columns the web UI should display. The order in the list matches the order in which the columns are displayed in the web UI. For example, note that the Tags column is deselected in the list and that the corresponding column is missing in the web UI display. The Tags column would have been displayed between the Name and Type columns. You can define three types of rules in a security policy. Each rule type specifies whether a rule applies to traffic within a zone, between zones, or both. An intra-zone rule applies to all matching traffic within the specified source zones. You cannot specify a destination zone for an intra-zone rule. For example, if you set the source zones to Zone A and Zone B, the rule would apply to all traffic within Zone A and all traffic within Zone B, but not to traffic between Zone A and Zone B. An interzone rule applies to all matching traffic between the specified source and destination zones. For example, if you set the source zones to Zone A and Zone B, and the destination zones to Zone A and Zone B, the rule would apply to traffic from Zone A to Zone B and from Zone B to Zone A, but not traffic within Zone A or within Zone B. A universal rule applies to all matching interzone and intrazone traffic in the specified source and destination zones. For example, if you create a universal role with source zones Zone A and Zone B and destination zones Zone A and Zone B, the rule would apply to all traffic within Zone A, all traffic within Zone B, all traffic from Zone A to Zone B, and all traffic from Zone B to Zone A. By default, the firewall implicitly allows intrazone traffic and implicitly denies interzone traffic. These implicit actions are predefined by the mostly read-only intrazone default and interzone default rules. By default, these two rules are processed after all of the explicit administrator-defined rules on the firewall and match traffic that has not matched any other security policy rule. The interzone default rule eliminates the need to create a rule that blocks all traffic not explicitly allowed by a security policy. The default firewall behavior is to log to the traffic log all traffic that is matched to an administrator-defined security policy rule. By default, traffic allowed or denied by the implicit security policy rules is not logged on the firewall. However, Palo Alto Networks recommends that you log all traffic and change the default behavior. Logging and logging configuration are described later in this module. Caution though, placing an explicit deny all rule at the end of your administrator-defined policy rules, but before the predefined intrazone default rule, will deny all intrazone traffic. This explicit deny all rule can disrupt normal application traffic flowing within your networks. Security policy rules are evaluated for a match from top to bottom. After a rule match is found, no other rules are evaluated. Policy rules are unidirectional, which means that they allow only traffic that is initiated in the direction that the policy rule specifies. Source zone or zones to destination zone or zones. The replies to the client always are allowed as part of the policy. If traffic is intended to be initiated in both directions, two policy rules are recommended, one for each direction. In the configuration shown, when the application web browsing on TCP port 80 from the trust zone to the untrust zone passes through the firewall, Rule A matches the traffic because the traffic matches web browsing in the application column and TCP port 80 matches any in the service column. The optimal way of configuring security policy rules is to minimize the use of any in the columns and use specific values when possible. Reducing the use of the word any reduces unnecessary security policy lookups by the firewall. In the example, the IP address 192.168.1.3 belongs to the trust zone, and the subnet 192.168.1.0/24. Because the firewall does a security policy lookup from top to bottom, all traffic from IP address 192.168.1.3 matches Rule A. Although the traffic from 192.168.1.3 also matches Rule B and Rule C, these rules will not be used because Rule A matches first. This behavior between security policy rules is called shadowing because Rule A casts a shadow over or hides Rule B and Rule C. At a minimum, Rule B and Rule C should precede Rule A to avoid shadowing in this example. Rule A could also be removed and replaced by another, better defined rule. The commit status window warns when one rule shadows one or more other rules. Use the information provided in the commit status window to reorder or modify the rules to remove shadowing. Security Policy Administration. To create a new security policy rule, browse to Policies, Security, and click Add. The Security Policy Rule window has 7 tabs that enable you to configure or modify a security policy rule. The decision about which tabs you use and which fields you complete depends primarily on the level of granularity that you require in your match conditions.
Don't be sucked in by the cuteness. It's a trap. We are just a can openers with legs for them. Once they figure out how to open a tin of food, they'll murder us all in our sleep. A refugee settlement. What about Ukraine? Huh? What about our refugees? Fucking people.
Click the Source tab to add, view, or modify the source zone and source address match criteria for a rule. The default source zone is any. You can select one or more source zones for a rule. Multiple zones are used to simplify policy management. For example, if you have 3 different internal source zones that should all have access to the same destination zone, you can create a single rule to cover all these cases. You can specify one or more source addresses. The default is any address. The source address can be a single address, an address range, an address group, or a geographical region. All of these choices are available when you click Add. The creation of address objects that encompass multiple addresses is described later in this module. The Negate option enables you to specify addresses, address ranges, address groups, or geographical regions that will not match the traffic. For example, consider the scenario where the network address 201.10.10.0/24 has been added to the source address field. In this scenario, the rule would match all source addresses that are not in the network 201.10.10.0/24. To create a new security policy rule, browse to Policies, Security, and click Add. The Security Policy Rule window has 7 tabs that enable you to configure or modify a security policy rule. The decision about which tabs you use and which fields you complete depends primarily on the level of granularity that you require in your match conditions. Click the User tab to add, view, or modify the source user and HIP profile match criteria for a rule. Before you can use source users or groups as match criteria, you must enable the User ID feature that maps IP addresses to user names. The firewall can use locally defined user and group information, or it can acquire user and group information from a distributed service such as LDAP or Radius. Use of a distributed service for user and group information requires additional firewall configuration. The default for the source user is any. However, you can specify one or more source users or user groups as match criteria. The following source user types are supported. Any includes any user of any type. Pre-logon includes remote users that are connected to the network using Global Protect but are not logged into their system. When the pre-logon option is configured on the Global Protect portal for Global Protect clients, any users who are not currently logged into their system will be identified with the username pre-logon. You can create policy rules for pre-logon users, and although the users are not logged, their systems are authenticated as if they were fully logged in. Known user includes all authenticated users, which means any IP address with a username mapped to it by user ID. Unknown includes all unauthenticated users, which means any IP address that are not mapped to a user by user ID. For example, you could use unknown to match a host where no user has logged in, and yet the host needs network access to perform a Microsoft update. Select includes selected users or groups that have been added using the add link. For example, you might want to add one or more specific users or user groups. The default for HIP profiles is any. A HIP profile defines a collection of machine attributes. The addition of a HIP profile to a security policy rule enables you to define the characteristics that a machine must possess before it is allowed to connect to network resources. For example, a HIP profile enables you to collect information about the security status of your end hosts, such as whether they have the latest security patches, whether they have encrypted disks, or whether they have a particular vendor's latest antivirus definitions installed. To create a new security policy rule, browse to Policies, Security, and click Add. Click the Destination tab to add, view, or modify the destination zone and destination address match criteria for a rule. The default for destination zone is any. You can select one or more destination zones for the rule. Multiple zones are used to simplify policy management. For example, if you have a source zone that should have access to 3 different destination zones, you can create a single rule to cover all these cases. You can specify a destination address. The default for destination address is any. The destination address can be a single address, an address range, an address group, or a geographical region. All of these choices are available when you click Add. We describe creation of address objects that include multiple IP addresses later in this module. The negate option allows you to specify addresses, address ranges, and address groups or geographical regions that will not match the traffic. For example, consider the scenario where a network address 212.45.1.0/24 has been added to the destination address field. In this scenario, the rule would match all destination addresses that are not in the network 212.45.1.0/24. To create a new security policy rule, click the Application tab to add, view, or modify the applications to use as match criteria for the rule. Click Add to add specific applications. If an application has multiple functions, you can select the overall parent application or individual child functions. If you select the parent application, all child functions are included. If Palo Alto Networks adds child functions to the parent, the new child functions are automatically added if the parent application is allowed. For example, the parent Facebook application includes Facebook Chat, Facebook Mail, Facebook Apps, and many other functions. Selection of the parent Facebook application automatically includes all the other Facebook functions. Alternatively, you can explicitly select only specific functions, which would disallow the application's non-selected functions. To create a new security policy rule, browse to click the Application tab. To create a new security policy rule, browse to click the Service URL Category tab. To add, view, or modify the services and URL categories to use as match criteria for a rule. Click Add to add specific services or URL categories. The service drop-down list has the following three choices. Any application is allowed or denied on any protocol or port. This rule choice is the least restrictive. Application default. Applications are allowed or denied on only their default protocol ports as predefined in the Palo Alto Network's Application ID database. To display application information, browse to Objects, Applications. The application default option is recommended when a policy rule allows a connection because it prevents applications from running on unusual ports and protocols. Unusual ports and protocols can be a sign of malicious application behavior and use. Note that even with the application default setting, the firewall still checks for all applications on all ports, but the rule would only match applications connecting with their default ports and protocols. Select. Click Add and select an existing service. A service is an object that defines a protocol and one or more ports. Only service HTTP or TCP 80, 8080, and service HTTPS or TCP 443 are predefined, but you can create your own custom services. Palo Alto Networks maintains the PanDB URL category database that divides millions of URLs into dozens of topic categories such as alcohol and tobacco, auctions, and business and economy. A firewall that has a valid URL filtering license can access this database and use URL categories as part of a security policy rule. URL filtering is described in more detail in another module. To create a new security policy rule, browse to Policies, Security. Click the Action tab to view or modify the actions taken on matched traffic. Allow, default action. Deny, blocks traffic and enforces the default deny action defined for the application that is being denied. Drop, silently drops the traffic. For an application, it overrides the default deny action. A TCP reset is not sent to the host application. To send an ICMP unreachable response to the client, select the Send ICMP Unreachable checkbox. Reset client sends TCP reset to the client or traffic initiator device. To send an ICMP unreachable response to the client, select the Send ICMP Unreachable checkbox. Reset server sends TCP reset to the server or traffic responder device. To send an ICMP unreachable response to the client, select the Send ICMP Unreachable checkbox. Reset both client and server. Sends TCP reset to both the client and server devices. To send an ICMP unreachable response to the client, select the Send ICMP Unreachable checkbox. Palo Alto Network's firewall protection is based on application intelligence, so in the case of TCP, a TCP session must be established before an application can be discovered. However, after a TCP session has been established, silent dropping of packets without sending a TCP reset can be dangerous. The drop action could break the application and cause it to behave improperly. An application might hang, continue to send packets, or unnecessarily hold system resources open. For these reasons, the default deny action defined for more than half of the applications recognized by the firewall is to send a TCP reset. The default logging action is to log only at the session end. However, you also may enable logging at session start, which is normally done only in the short term for troubleshooting purposes. Addition of logging at session start captures the initial connection setup and any initial application identification. The primary drawback with logging both session start and session end is the additional load on the management plane CPUs and the additional storage space required for the log entries. To create a new security policy rule, browse to. By default, a security policy rule always is in effect. However, you can define and apply a schedule to a rule that limits when the rule is in effect. To define a schedule, browse to Objects, Schedules, and click Add. The firewall schedule supports a daily schedule with multiple start and end times. It also supports a day-of-the-week schedule for those situations where a scheduled change should not occur every day of the week. You still can specify multiple start and end times to any scheduled day of the week. The scheduler also supports a non-recurring schedule where you specify a start date and time followed by an end date and time. A non-recurring schedule also supports multiple start and end times. After you have defined a schedule, browse to Policies, Security, select a rule, and click its Actions tab. Select your schedule from the Schedule drop-down list. Established sessions are not affected by a rule made active by the scheduler. For example, an existing FTP session would not be blocked if a scheduled rule that blocks FTP becomes active. Only new FTP requests would be blocked after the scheduled rule becomes active. After rules are created, they will be listed and numbered. The numbers in the first column are not part of the rules and never move when a rule is moved. The toolbar below the rules helps you to manage the rules and enables you to perform a number of actions on your rules. To add a new rule, click Add. To delete a rule, select it and click Delete. To use an existing rule as a template to create a new rule, select it and click Clone. To modify an implicit intra-zone default or interzone default rule, select it and click Override. To revert it to its original state, click Revert. To disable a rule without removing it, click Disable. You can disable a rule to stage it or temporarily take it out of commission to troubleshoot a problem. A disabled rule displays in a gray italic font. Remember that the firewall matches traffic to rules from the top down, so arrange the rules in the proper order to yield the desired behavior. The web UI provides multiple methods to reorder rules. You can use the Move option by first selecting the rule that you want to reorder. After you select a rule and click Move, you are presented the options to move the rule up, down, to the top, or to the bottom. You also can use the mouse pointer to drag and drop a rule to the desired location within your rule set. Administrators should cull their security policy rule base from time to time. You can perform cleanup quickly and easily by using the Highlight Unused Rules option. The Highlight Unused Rules option enables you to see which rules have not matched any traffic since the last restart of the data plane. This option can be used to troubleshoot a misconfigured security policy. This option also can be helpful if you migrated your rules from a previous non-Palo Alto Networks firewall solution. An address object is a name-value pair that can represent a single IP address, a range of addresses, an IP subnet, or an FQDN. You can use an address object in the source or destination IP address fields in a security policy. An address object also can be used in any of the other policy types on a firewall. Address objects are useful to simplify firewall administration by enabling you to create the object once and then reuse it multiple times across different policy types. When the IP address or range defined for the address object changes, you can edit the address object. The change in value automatically will be inherited by all instances where the address object is used. Consider using an address object in the destination address field to enable access to specific internal servers or groups of servers only, particularly for services such as DNS and SMTP that are commonly exploited. By restricting users to specific destination server addresses, you can prevent data exfiltration and command and control traffic from establishing communication through techniques such as DNS tunneling. To create an address object, browse to Objects, Addresses, and click Add. The three types of address objects are IP net mask, specifies a single IP address like 192.168.1.1 or an IP subnet 192.168.1.0/24. IP range specifies a range of IP addresses 192.168.1.1 to 192.168.1.10. And FQDN specifies a fully qualified domain name. For instance, hosta.west.paloaltonetworks.com. For only address objects containing FQDNs, the list of FQDNs can be changed without the need to recommit the firewall configuration. The FQDNs are resolved by the firewall and are refreshed after their DNS time to live value has expired. Tags enable you to group objects using keywords or phrases. Tags are optionally assigned a color, which makes visually searching for a tag easier in the web UI. You can use a filter in the web UI to quickly display only those objects that have been assigned a particular tag. In the example, a filter for the tag name Mail Servers Rule was applied to the Security Policy Rule set, which caused only the explicit rules with that tag to be displayed. Implicit rules are always displayed. Tags can be assigned to address objects, address groups, zones, services, service groups, and policy rules. You can assign multiple tags to a rule or object. If a rule or object is assigned multiple tags, only the color of the first assigned tag is displayed. To create a tag, browse to Objects, Tags, and click Add. Provide a descriptive name for the tag based on its purpose. Optionally, choose a color for the tag and add comments that describe the tag. When you define security policy rules for specific applications, you can select one or more services to limit the port numbers that the applications can use. The default port for services in security policy rules is any, which enables an application to use any TCP or UDP port. The only predefined service definitions are service HTTP and service HTTPS, but you can create additional service definitions. To create a new service definition, browse to Objects, Services, and click Add. Provide a descriptive name for the new service and, optionally, provide a description of the service. Select either the TCP or UDP protocol because both cannot be simultaneously selected. Then specify the allowed destination ports between 0 and 65.535. You can list a single port number, a hyphenated range of port numbers, or a comma-separated list of port numbers. Or you can specify ports by mixing and matching all of these formats. Specification of source port numbers is optional. You can also specify a tag. Global Find enables you to search the candidate configuration and content databases on a firewall for a particular string, such as an IP address, an object name, a policy rule name, a threat ID, or an application name. Global Find is launched from the search link or from a content menu. The search results are grouped by category. Links are provided to the object's location in the web UI so that you can easily view all of the places where the string is referenced. The search results also help you identify other objects that depend on or make reference to the search string. For example, if you are deprecating an application, enter the application name in Global Find to find all instances of the application, and then click each instance to navigate to the configuration location and make the necessary changes. Global Find will not search dynamic content, such as logs, address ranges, or allocated DHCP addresses. Global Find also does not search for individual user or group names identified by user ID, unless the user group is defined in a policy. In general, you can only search content that the firewall writes to the candidate configuration. Example use cases for the Global Find feature are: a user wants to find all objects with a given tag. A user wants to see where a given IP address is used in the configuration, including address objects, dynamic objects, literals in policies, and network configuration. A user wants to find a policy that includes a user name or user group. A user wants to see any place a given username appears in the config, including user activity reports and policies. A user wants to find out if an application is used in a policy, application group, application filter, or a report query. And a user wants to find a ticket number that was added to a comment in a policy or on another object. By default, the implicit intrazone default and interzone default rules do not generate traffic log entries. However, you can enable logging on each of these rules so that you can see all traffic encountered by your firewall. To configure logging on the implicit rules, select a rule and click Override.
Rakesh, who's paying for her food?
Then choose to log at session end, or for short-term troubleshooting purposes, log at both session start and session end. In addition to having logging capabilities, you can apply security profiles to the default intrazone and interzone policy rules. We describe security profiles in another module. Each security policy rule can be configured to log session information to the traffic log. The default is to log at session end. However, you can choose to not log at all, log at session start, log at session end, or log at both session start and session end. Traffic logs show entries for each URL category transition only if log at session start is also configured. Under normal circumstances, logging at session end is sufficient to view firewall operation. If you need to troubleshoot firewall operation, then you might need to temporarily configure one or more security policy rules to log at session start and session end. Logging at session start and end will place additional load on the management plane CPUs and consume more disk space to hold the additional log entry information. The type column indicates whether the entry is for the start or end of the session, or whether the session was denied or dropped. The type drop indicates that the security rule that blocked the traffic was configured to match any application. If the firewall drops the traffic before the application has been identified, the application column displays "Not applicable." The type deny indicates that the security rule was configured to match and block a specific named application. Click the magnifying glass icon next to an entry to display additional details about the session. For example, a count value greater than 1 indicates that an ICMP entry aggregates multiple sessions between the same source and destination. Network address translation. Administrators are better equipped to create security policy rules and NAT policy rules if they understand how the firewall processes packets and uses NAT to translate IP addresses. Security policy rules must allow traffic that will be manipulated by NAT policy rules. The Layer 3 information is processed when the packet is received by the firewall, before the deep inspection of the packet and its payload begins. At this stage in the logic flow, the NAT policy is evaluated to determine if packets would be subjected to a NAT policy rule, and, if so, the kind of translation that is applicable. However, no translation takes place yet. The packet retains all original header information. This retention has implications for the security policy rules that will be matched to the NAT traffic. NAT configuration can take two forms, source NAT and destination NAT. The forms are directional and are described from the perspective of the NAT device, the firewall. You often will use source NAT to translate the address of outbound traffic, that is, traffic originating on a private network and being forwarded out toward the Internet. You often will use destination NAT to translate the address of inbound traffic, that is, traffic coming from the Internet into the local private network. For both source and destination NAT, the firewall maintains the mapping of pre-NAT to post-NAT IP addresses. In the example shown, both the Trust L3 zone and DMZ zone are within the private network. The Untrust L3 link is the firewall's connection to the Internet. Note, this example shows the common practice of creating a DMZ zone for the purpose of securely segmenting externally accessible web servers. Source NAT configuration. Source NAT, by definition, changes the source address of packets that match the NAT policy as the packets transit the firewall. Depending on the firewall configuration, source NAT also might change the source port number. Source NAT commonly is used to allow host devices configured with a private IP address to send and receive traffic on the Internet. This graphic shows the firewall performing a source NAT function. A host residing at 192.168.15.47 on the private network needs to access a service residing at 203.0.113.38 on the public Internet. The firewall receives the host traffic on the Trust L3 interface and forwards it on the Untrust L3 interface, replacing the original source IP of the packet with the configured Untrust L3 interface IP of the firewall. Without this translation, traffic from the host would be discarded by the ISP carrier because it would be sourced from a private address, 192.168.15.47. Source NAT translates the private address and makes the traffic routable across the Internet. Source NAT types provide the administrator different options for setting the size and nature of the translated source address pool. The firewall supports three ways of provisioning a translated source address pool. Static IP. Static IP is used to change the source IP address while leaving the source port unchanged. Note, use of the bidirectional option in static source NAT rules implicitly creates a destination NAT rule for traffic to the same resources in the reverse direction. To configure source Static IP. Static IP is used to change the source IPs in the reverse. Source NAT, by definition, 192.4 and makes the traffic routable across the Internet. Static IP. Static IP is used to change the source IP address while leaving the source port unchanged. Note, use of the bidirectional option in static source NAT rules implicitly creates a destination NAT rule for traffic to the same resources in the reverse direction. To configure source NAT, first create a NAT policy rule. When you create a source NAT policy rule, identify the original packet characteristics. Use the fields in the Original Packet tab to define the match criteria that will be used to select traffic for the NAT translation. A NAT policy rule matches the packet based on the original pre-NAT source and destination addresses and the pre-NAT destination zone. Then create a security policy rule to support the NAT traffic flow. The security policy rule will include source, destination, and application characteristics along with an action. Because of the flow logic discussed, you know that security policy rule is enforced after the NAT policy rule is evaluated, but before the NAT translation is applied. Therefore, as is shown, a security policy rule matches the packet based on the original pre-NAT source and destination addresses, but matches the post-NAT destination zone. Note, the rule action must be configured as allow to permit traffic matching the defined characteristics to cross the specified zone. In this example, a host with the IP address 192.168.15.47 wants to connect to a server on the Internet residing at IP address 203.0.113.38. To support this connectivity, the firewall administrator has configured a NAT policy rule so that all traffic from the private network appears to come from the publicly routable address on the Ethernet 1.4 interface. For this configuration, the administrator has chosen to use the DIP type source NAT. When you configure DIP, use address type to define addresses for the pool. There are two options. The translated address option uses a new address that is not on an external interface. It is used for interfaces that receive an IP address dynamically from a pool. The interface address option uses an existing address that is on an external interface. In the example shown, the interface address option was used, and the interface specified is Ethernet 1.4 with IP address 198.51.100.22. NAT rules are based on source and destination zones, source and destination IP addresses, and application services. As with security policy rules, NAT policy rules are compared against incoming traffic in sequence. The first rule that matches the traffic is applied. Every NAT policy rule is configured in the web UI under Policies, NAT. To configure source NAT, use the original packet to define the source and destination zones of the packets that the firewall will translate and, optionally, specify the destination interface and type of service. You can configure multiple source and destination zones of the same type, and you can apply the rule to specific networks or specific IP addresses. Select the Translated Packet tab to configure the type of translation to perform on the source and the address and/or port to which the source will be translated. Although the General tab is not shown in this graphic, it is used to name the NAT policy and to specify which type of traffic the NAT rule will translate. Options are IPv4 for translation between IPv4 addresses, NAT 6-to-4 for translation between IPv6 and IPv4 addresses. This option most commonly is used for connecting IPv6 corporate internets to the Internet. And NAT v6 for translation between IPv6 addresses. Examples in the module will use translation type IPv4 because it is the most common type implemented. Translated packet characteristics determine what translation will be done with packets that match the criteria defined under the Original Packet tab. Translated packet characteristics include translation types. 3 translation types correspond to the 3 types of source NAT. Static IP. For this type, a single original packet IP address is mapped to a single translated packet IP address. The same address is always used and the port is unchanged. For example, if the configured source range is 192.168.0.1 to 192.168.0.10 and the configured translation range is 10.0.0.1 to 10.0.0.10, address 192.168.0.2 is always translated to 10.0.0.2. However, the number of source IPs using this policy must exactly match the translated address range.
What?
For a given IP address, the TCP protocol recognizes a maximum of about 64,000 port numbers. That's 16 header bits for source port, yielding 65,536 total, minus 1024 well-known, equals 64,512 available ports. Based on this limitation, DIP source NAT will support a maximum of about 64,000 concurrent sessions on each IP address configured within the NAT pool. On some platforms, the Pan-OS DIP NAT implementation supports oversubscription. Oversubscription allows the reuse of port numbers by using destination IP address as an additional NAT session identifier. In the example shown, the same post-NAT translated source IP and source port are being used for traffic streams flowing to 4 different IP addresses, which constitutes 4 times oversubscription. The NAT oversubscription rate is configurable up to a maximum rate supported by the platform. To view the oversubscription information for each firewall model, refer to paloaltonetworks.com/products/product selection.
Fatty, you did pee, right? No, you did pee now. This is my gown, right?
I'm not talking to you for
This is
10
my
days.
this is my gown.
I'm not talking to you for 10
Where
days.
the last drop goes?
On your gown.
Wow, блядь, ты такая.
Destination NAT configuration. Destination NAT, by definition, will change the destination address in the IP header of packets that match the NAT policy as they transit the firewall. Destination NAT commonly is used to make a server within a private network reachable from the public Internet. In the example shown, a user at an external system with the IP address 192.0.2.5 queries the DNS server for the IP address of the web server www.example.com. The DNS server returns an address of 198.51.100.22, the external address of the firewall interface in the untrust L3 zone. For the packet to reach the web server, the destination IP address must be translated to the private IP address 192.168.16.2. Destination NAT provides the administrator options for provisioning public access to servers and services within their network. Destination NAT uses static IP mapping with optional port forwarding. Static IP is used for one-to-one translation of inbound traffic. Static IP allows you to change the destination IP address and, optionally, the port. When destination address translation is used to map a single public IP address to multiple private servers and services, destination ports can stay the same or be directed to different destination ports. Use static IP to change the destination IP address while leaving the destination port unchanged. Port forwarding is a NAT technique used to manage traffic based on destination port numbers. For example, assume that a company has separate servers for email, web hosting, and applications. All three reside in a zone named DMZ. All systems in DMZ are externally reachable through a NAT policy that maps them all to the same IP address. When traffic is received at the shared address, the port forwarding feature of the NAT policy sends the traffic to the appropriate server based on the destination port associated with the session. To configure destination NAT, first create a NAT policy rule. When you create a destination NAT policy rule, identify the original packet characteristics. Use the fields in the Original Packet tab to define the match criteria that will be used to select traffic for the NAT translation. A NAT policy rule matches the packet based on the original pre-NAT source and destination addresses and the pre-NAT destination zone. Use the Translated Packet tab to specify the desired translation of packets that meet the original packet criteria. Then create a security policy rule to support the NAT traffic flow. The security policy rule will include source, destination, and application characteristics along with an action. Because of the flow logic discussed, you know that the security policy is enforced after the NAT policy is evaluated, but before the NAT translation is applied. Therefore, as is shown, the security policy rule matches on the post-NAT zones and the pre-NAT destination IP addresses. In this example, a user with IP address 192.0.2.5 wants to browse web pages hosted at www.example.com. Though DNS resolution is not shown in the diagram, you should assume that example.com is associated with 198.51.100.22, the IP address on the E14 interface of the firewall. To support this connectivity, the firewall administrator has configured a destination NAT policy rule so that traffic arriving at E14 destined for 198.51.100.22 has its destination address changed to 192.168.16.2. After determining the translated address, the firewall performs a route lookup to determine the egress interface. In this example, the egress interface is E12. To support this traffic flow, the administrator has configured a security policy rule. The security policy rule permits web browsing traffic from the pre-NAT zone, untrust L3, with a pre-NAT destination IP address of 198.51.100.22 to cross into the DMZ zone. Configuration of destination NAT is similar to configuration of source NAT. As with source NAT, destination NAT uses the Original Packet tab to define the source and destination zones of the packets that the firewall will translate, and, optionally, specify the destination interface and type of service. You can configure multiple sources and destination zones of the same type, and you can apply the rule to specific networks and specific IP address. Select the Translated Packet tab and check the Destination Address Translation box to flag this rule as a destination NAT rule. Leave the source address translation type set to none if this rule is a destination NAT only rule. Note, NAT rules must be configured to use the zones associated with pre-NAT IP addresses configured in the policy. In the example shown, the source and destination zones are the same. A security policy differs from the NAT policy in that post-NAT zones must be used to control traffic. NAT may influence the source or destination IP addresses and can modify the outgoing interface and zone. When you create security policy rules with specific IP addresses, the pre-NAT IP addresses are used in the security policy rule match. Traffic subjected to NAT must be permitted explicitly by the security policy when that traffic traverses multiple zones. PAN-OS software supports two destination NAT types. Static IP, which is used for one-to-one translation of inbound traffic. Configuration of static IP destination NAT changes the destination IP address while leaving the destination port unchanged. Port forwarding, which is a technique used to manage traffic through NAT policies based on destination port numbers. For example, assume that a company has 3 separate servers for email, web hosting, and an application server that exists in a zone named Server Trust. All systems in Server Trust are configured with a NAT policy to appear as if they have the same IP address. When traffic is received at the shared address, the port forwarding feature of the inbound NAT policy can send the traffic to the appropriate server based on the destination port associated with the session. To configure destination NAT, enter an IP address or range of IP addresses and a translated port number, 1 to 65535, that the destination address and port number are translated to. If the translated port field is blank, the destination port is not changed. Destination translation typically is used to allow an internal server, such as an email server, to be accessed from the public network. The translated address field can be completed with either an IP address or an address object. Address objects are named objects configured on the firewall to help administrators more easily complete configurations with a predefined address. To configure address objects, go to Objects, Addresses.